Rosalind is a passionate Android developer. She has already developed and published a lot of useful apps. However, she wished to allow other platform users to benefit from her apps without having to develop them again.
Frank and his team are app developers. They are working on a large application that needs to be deployed for multiple platforms. They found out that using any cross-platform tool won't support the graphics and the performance they want in their app. But developing the app natively for every platform takes a lot of time.
Laura is an iOS developer. She found that other platforms hold a bigger share of the app market than iOS. In order to expand her business, she considered deploying her applications for Android users. However, she cannot waste time becoming a complete Android developer. We are the team of TCAIOSC, and in this video, we'll show you how TCAIOSC is the ultimate solution for the previous use cases.
With the increasing number of mobile device users, mobile app development is now highly demanded in order to serve the needs of the high number of mobile users. There are different kinds of mobile phones that host different operating systems. Every mobile developer usually wishes to deploy their application for all kinds of phones to reach all possible end users. To achieve this, engineers and developers use various methods to accommodate different operating systems or environments. This practice is called cross-platform development. The idea of cross-platform development is that a software application or product should work well in more than one specific digital habitat. In traditional mobile application development, after the business need is determined and the requirements are collected, an application goes through multiple development cycles. Each cycle results in the solution implemented in a specific platform and supplied to its customers. On the other hand, in cross-platform development, the application goes through only one development cycle and can then be deployed to different platforms. Lots of cross-platform development solutions are now used, such as PhoneGap, Xamarin, Megdom, and J2 Objective-C. Although these cross-platform tools are now majorly used for mobile application development, they have their limitations that don't usually align with the application's requirements. In addition to having lower performance compared to native applications, some of the tools require the developer to learn new frameworks and programming languages. Some only support backend code conversion, and others require higher memory usage. A proposed solution would be a cross-platform development tool that gathers between achieving the advantages and avoiding the limitations of cross-platform development. That's why we came up with TCAIOSC. TCAIOSC is a web application that converts a native Android application project to a native iOS application project and vice versa. It's a short for Transcompiler-based Android to iOS converter. Pretty long, huh? Transcompilers are a type of systems that convert a high-level language to a high-level language basis. And since Android and iOS hold the biggest market share of mobile application platforms, we decided that the source and the target platforms should be Android to iOS and the other way around. So what's really special about TCAIOSC? Firstly, TCAIOSC doesn't only convert backend code functionality, but it also provides the advantage of converting the app user interface to look exactly like the source. Moreover, using Transcompiler approach built a strong structure for TCAIOSC. Since it produces a high-level language output, it doesn't just produce a cross-platform executable app. It actually outputs a converted project, in which the developer can edit and change anything. A developer has the opportunity to generate the corresponding platform project using their native project, without the need to learn any other languages by heart, and is also provided with maximum flexibility for code generation. We're supporting new UI libraries or even new features in the programming language itself requires minimum effort. Since our tool is a transcompiler, it processes the source code by building its parse tree, using pairs of a lexer and a parser. Lexers and parsers are obtained from a parser generating tool named Antler. Basically, Antler takes in the source language grammar file and outputs the language lexer and parser, which are then used as components of our tool. Accordingly, to convert the source code, the code is passed to the lexer. Resultant tokens are passed to the parser. The build parse tree is fed to the converter, which finally outputs the target code. Using Antler turned out to be an innovative solution to parsing and a strong basis for TCAIOSC.
Let's take a look at TCAIOSC architecture. The source project goes through multiple stages before the target project comes out. First stage is the controller. The controller divides up the project into three sets of files: backend code files, user interface files, manifest, and other resources. The code converter will convert this file by working on the parse tree and using the database that stores the mapping between Android and iOS. And during conversion, the code converter collects data, like the name of the corresponding user interface file, the user interface objects created in the backend file, and other things that might affect the conversion of the corresponding user interface file. When the code converter completes the conversion process, it returns the equivalent code and the data collected back to the controller. After the controller receives the results from the backend converter, it creates a new file for the generated code and checks the corresponding UI file name. Then the controller fetches this UI file and passes it to UI converter for conversion. Then the UI converter converts the file with the help of the database that stores the mapping of the UI components between Android and iOS. After the UI converter completes its process, it returns the equivalent UI code back to the controller. After that, the controller repeats the process with the conversion of the next backend file, till no files are remaining.
To sum up, here is the demo of how to use TCAIOSC in the Android to iOS direction. Our team was always keen on making the best out of challenges to get TCAIOSC out in its best shape. For example, difference in software design patterns in Android and iOS for the same functionality. Android and iOS use different software patterns and architecture. For instance, responding to user events in Android is implemented via observable software pattern. but in iOS, it is implemented via target action pattern. This made the conversion unexpectedly hard. However, the database was modified by creating separate section only responsible for handling these patterns. We were also confronted by the fact that backend code in Android is not necessarily converted to backend code in iOS, but it might affect the UI code as well. This was solved by making the backend code conversion unit identify these types of code, save them in a list, and pass the list to the UI conversion unit when it comes to converting the corresponding UI file. Finally, handling the unsupported code was a tricky task. There will always be new features and APIs added to Android and iOS. And until the database is updated, the code that TCAIOSC cannot convert will be commented in the output with a to-do comment for the developer. Then, the developer can write the corresponding code themselves. Our journey with TCAIOSC was quite enriching as well as amusing. We hope any questions you have about our project are answered through our report, and we'd all like to thank you for giving us the opportunity to talk about TCAIOSC.